So I was looking at my laptop the other day, and it just kind of hit me.
Mm-hmm.
The complexity inside this thing, or, an electric car, a wind turbine. They all need these materials you never really think about. Rare earth elements, REEs.
Right, they're in everything high-tech. Absolutely critical.
But what if the next big source for them wasn't some deep, complicated mine?
Mm.
But, I don't know, simple fern.
Well, that's exactly what we're diving into today, this idea of phytomining. You've hit on the core issue. Traditional mining is, well, it's fraught with environmental and geopolitical problems.
It's a tough supply chain.
A very tough one. So this plant-based solution, phytomining, it's emerging as this truly innovative alternative. It completely reimagines how we get these resources.
Okay, so let's get into it. The specific plant we're talking about is a fern called Blechnum orientale. And it was already known as a hyperaccumulator, right?
Yes, which means it's brilliant at sucking up high concentrations of metals from the soil without, dying.
But the new research found something else. A kind of superpower.
This is the wow moment. A complete surprise even for the researchers. They found the fern is naturally forming tiny crystals inside its tissues. Nanoscale monazite crystals.
Monazite. Now, that's a big deal because that's a prized industrial ore for rare earths.
A very prized ore. And in nature, it only forms deep underground. We're talking immense heat, immense pressure over millennia.
So this plant is, it's basically performing millions of years of geology right there in its leaves at room temperature.
That's the perfect way to put it. It's a fundamental challenge to how we think about mineral formation. The plant is actively self-assembling these elements.
Why? What's the point for the fern?
It seems to be a self-protection mechanism, a brilliant one. It's packaging and sealing these rare earth ions, which could be toxic, into stable, harmless little crystals.
Okay, I have to ask about this then. Natural monazite, it's often associated with radioactive elements like uranium and thorium. That's a huge issue.
A huge regulatory and safety issue, yes.
Does this biomonazite from the fern solve that?
It absolutely appears to, and this is another game changer. The biomonazite is noted as pure and critically non-radioactive. It just avoids that whole contamination problem.
Wow. That would simplify things enormously.
Enormously. It cuts out a massive step in processing and regulation.
So let's walk through the commercial process. The 3 stages of phytomining. It has to start with the plants themselves.
Right. Stage 1 is phytoextraction. You cultivate fields of these hyperaccumulator ferns. The orientale is one. Another amazing one is Dicranopterus linearis. They just pull the REEs from the soil into their leaves and shoots.
They're like little biological miners.
Exactly. Then comes stage 2, enrichment. You can't just process tons of leaves. It's not economical.
You have to concentrate it down.
Precisely. And this is done through thermal conversion, basically controlled ashing. You reduce all that plant biomass into what they call bioores.
And that's where the concentration really happens.
Oh, yeah. In one study with Dicranopterus linearis ash, the REE concentration was enhanced about 11 times.
11 times. And because it's just burning biomass, the energy footprint has to be way lower than, say, a traditional smelter.
Way lower, which is a key part of this being a green strategy. And that makes stage 3, the final extraction, much more viable.
Okay, so you take that concentrated bio-ore, and then you use more standard techniques to get the pure metals out.
Correct. You can use existing or new hydrometallurgical methods to isolate the REs.
Setting up a whole new supply chain like this, from the farming to the processing, it requires so much data, so much analysis to optimize.
Oh, absolutely. And covering all those patterns and making it efficient, that's a huge challenge.
And that's actually a great connection, because this deep dive is sponsored by Embersilk. If you need help uncovering where AI agents could make the most impact for your business, or you need assistance with AI training, automation, or software development, you should check out embersilk.com for all your AI needs.
A perfect fit for a topic like this.
It really is. So this whole approach, it feels like it substantiates phytomining as a real path forward, not just a novelty.
It's a genuine green strategy. And think about the side benefits. You get progressive soil decontamination, minimal land disruption. It's a way to complement traditional mining for a more secure, sustainable supply.
What's really inspiring to me, though, is the bigger picture here.
What's that?
That this discovery just felt. It proves that plants might hold all these incredible secrets about making minerals that we're only just starting to understand.
I completely agree. The next great resource discovery might not come from a drill bit. It might come from biology, from the ingenuity that's already happening right beneath our feet. It's a testament to the solutions nature already has.
A wonderful thought to end on, the sheer biological genius just waiting for us to discover. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.